In this video, we're going to look at how we can find the area underneath the curve. Now, what does that even mean? We'll say we have a question, right, that says find the area. So we'll say find the area under the curve represented by, and I won't write all that, so find the area under the curve represented by y is equal to 4x squared minus 8x plus 4 from 0 to 2. So 0 to 2 will be our bounds. Now, well, what does this graph even look like, right? There we go. That's what the graph looks like, okay? So this is what we're working with here, right? And if we want to find the area underneath the curve, right, what does that mean? It means, well, we're going from 0 to 2, right? So the area underneath the curve is going to be all this stuff right here that hits the x-axis, right? So we're not going below it, right? Now, we're not going to find all of this area because, again, we're only going from x equals 0 to x equals 2. So let's actually get into the problem. How do we solve this? Now, if you have been integrating for a while, you now know how to take the integral of a function, right? And that's exactly what we're going to do here. That's how we're going to find the area underneath this curve, right? If you remember learning MRAM, LRAM, RRAM, you know, all the Riemann sums, that's what this was trying, that's the point that this was trying to make, right? So here's what we're going to do. To find the area under the curve, 4x squared minus 8x plus 4, we're going to integrate it, right? So 4x squared minus 8x plus 4 dx, right? And now we're only doing this from x equals 0 to x equals 2. So those are going to be our bounds of integration. So we're doing a definite integral, right? So we have this all set up. We've interpreted our word problem, which in my opinion is the hard part. Now all we have to do is do the math. And this is some pretty simple stuff that you've probably been working with on for a few days, maybe a week or so. So we can take this integral, right? So if we take the integral of 4x squared, we raise the power by 1 and divide by that new power. So we get 4x cubed over 3, right? And then same thing with minus 8x. We're going to raise the power by 1, so it'll be raised to 2. And then we'll divide by that new power, right? So it'll become x squared. And then 8 over 2 is 4, so we'll just say minus 4x squared. And then 4, we know when we integrate any constant, it just becomes that constant times the variable of integration. So our variable in this case is x. So when we integrate 4, we get 4x. And we're going to evaluate this from 0 to 2, right? So here's what we do. Remember, definite integrals means we plug our upper bound into our equation first and then subtract our lower bound when we plug that into the equation. So let's plug in 2 to this whole thing right here. So we get 2 cubed, right? 2 cubed is going to be 2 times 2 is 4, times 2 is 8. So 4 times 8 is 32 over 3. And then minus 4 times 2 squared. 4 times 2 squared is 4 times 4, so that's 16. And then 4 plus 2 is 8, so we're going to do plus 8, right? So that's our whole upper bound evaluated for. And then our lower bound is 0, so normally if we had a different number, we would actually plug that in it and subtract that from our first upper bound equation, but since 0 is just going to evaluate to 0, we're going to subtract 0 from this, so nothing will happen. And that's our final answer. Our final answer is 32 thirds minus 16 plus 8. And of course, you could further simplify this. I just don't feel like doing that because there's fractions right now. But yeah, that's how simple it can be to solve this kind of problem. When you need to find the area under a curve, given some bounds, you just take the integral of that function with those lower and upper bounds. If you found this video helpful, thank you. I really appreciate it, and I hope you learned something.